2010 AMC10B, Problem 1. What is 100 times 100 minus 3 minus 100 times 100 minus 3? Alright, let's just calculate this. So the first expression, that's 100 times, in parentheses, 100 minus 3, that's 97, minus, in parentheses, 100 times 100, that's 1 with 4 zeros behind it, minus 3. Alright, so 100 times 97, that's 9,700, minus 10,000 minus 3, that's 9,997. So our answer is 9,700 minus 9,997. It's going to be negative. Let's just subtract 9,997 minus 9,700. That's 297. So our answer is negative 297, which is C. Problem 2. Macarla attended 2 meetings during her 9-hour workday. The first meeting took 45 minutes. The second meeting took twice as long. What percent of her workday was spent attending meetings? Alright, so we want the percent of her workday that was spent attending meetings. The total amount of time, her total workday, that's a 9-hour workday. Let's convert that to minutes since her meetings are in minutes. So let's make sure our units are consistent. So 9 hours, that's 9 times 60 minutes, right? Because there's 60 minutes in an hour. So the denominator is going to be 540 because 9 times 60, that's just 540. So we know there's a total of 540 minutes in her workday. Now, what percent of her workday was spent attending meetings? The first meeting took 45 minutes. The second meeting took twice as long. So what is twice 45? Well, that's 90, right? So the total amount of minutes she spent attending meetings is 45 minutes for the first meeting plus 90 minutes for the second meeting. That's 135 minutes total. So this is going to be our fraction. Let's simplify this a little bit. So we can see both top and bottom divisible by 5. 135 divided by 5 is 4. 540. Let's divide that by 5. That's 10. 50 minus 40. That is 8. So it's 4 out of 108. Alright, let's simplify that a little bit even more. And divide it on top. Oh, wait, 135 divided by 5. Sorry, I divided that wrong. That's 2 times 5 is 10 minus 35. 5 and 7, so it's actually 27. Sorry. I don't know why I wrote a 4 down. If you cancel out a factor of 5, it's going to be 27 over 108. But this is just 1 over 4. And we know 1 over 4 is 25%. And our answer is C. Problem 3. A drawer contains red, green, blue, and white socks with at least 2 of each color. What is the minimum number of socks that must be pulled from the drawer to guarantee a matching pair? So we know there's going to be a lot of red socks, at least 2 of each. So a lot of green, a lot of blue, and a lot of white. And we want to say we need to know the minimum number of socks that must be pulled from the drawer to guarantee a matching pair. So these types of questions we always want to look for the worst possible scenario. So the worst possible scenario is, we know to guarantee a pair, that just means 2 of the same color, right? Obviously, we could get lucky and immediately draw, for example, 2 red, then we'll have a pair, and then we'll be done. But that's not the worst possible scenario. The worst possible scenario is if we get as many of each kinds of socks without satisfying their condition, at least, to guarantee a matching pair. So if we grab a red, then a green, then a blue, then a white, this is the worst case scenario because we have 1 of each color, 1 of each sock, but we still don't have enough to guarantee a matching pair because we don't have 2 of the same color. But now for the next sock that we draw, it doesn't matter which sock we draw, we have to get a matching pair now. Because if we get a red, that matches up with the red. If we get the green, that matches up with the green, etc. So clearly this is the worst case scenario where we grabbed as much as we can of each color, of each sock. And then for our last sock, it doesn't really matter. It could be any sock. It has to match up with one of our previous socks. So we need at least 5 socks, because there's a total of 5 socks, to guarantee a matching pair. And our answer is C. Problem 4. For a real number x, define heart of x to be the average of x and x squared. What is heart 1 plus heart 2 plus heart 3 plus heart 4? Now let's just quickly calculate each of these expressions. So heart 1, that's going to be the average of 1 and 1 squared. So the average of these numbers. 1 plus 1 squared, that's just 2. Divide by 2, that's 1. Do the same thing. Heart 2, that's going to be average of 2 and 2 squared. 2, the average of x and x squared. So in this case, it's 2 and 2 squared. Divided by 2. It's just 2 plus 4, because 2 squared is 4. Divided by 2, that is 3. Finally, we have heart 3. It's going to be 3 plus 3 squared. The average of 3 plus 3 squared, so I have to divide that by 2. That's just 3 plus 9 over 2. We know 3 plus 9 is 12. Divide by 2, that's 6. So now I have to add these up. 1 plus 3 plus 6, that's 10. And our answer is C. Problem 5. A month with 31 days has the same number of Mondays and Wednesdays. How many of the 7 days of the week could be the first day of the month, of this month? Alright, so first of all, we know this month has 31 days. So what is the general format? So let's say it just started with Monday. Then we know we have Monday, Tuesday, Wednesday, Thursday. We would have this cycle. We could go to Saturday and then Sunday. That's 7 days. Then we would come back Monday, Tuesday, Wednesday, Thursday, Saturday, Sunday. That's 7 more days. We know 31 days. How many 31 days, how many weeks is that? Well, let's divide that by 7. 4 times 7 is 28 minus the 3. So that means we're going to have 4 full weeks. So we're going to have 4 full weeks. And then we still have a remainder of 3. So we still have an extra 3 days. Okay. So now how do you know how many of the 7 days of the week could be the first day of the month? So if the first day of the month was Monday, then we'd have Monday. The Monday would always be this first guy. Then we have the Tuesdays. Tuesday would be the first guy, and then the Wednesdays, right? And then the Wednesday would be this last guy. But then, as you can see, for the Thursdays, since the remainder of 3 is not there anymore, we can see that the Mondays, there's 5 Mondays, there's going to be 5 Tuesdays, there's going to be 5 Wednesdays, but there's only going to be 4 Thursdays, only 4 Fridays, etc. Because the remainder of 3 just means that the first 3 days, they get an extra day, right? And then the other remaining days, they don't get any extra days. So we can see that so then in this case, when Monday's the first day, that works. Because the Monday, there's 5 Mondays and there's 5 Wednesdays as well. You can see Mondays work. But let's say we tried Tuesday. If Tuesday was the first day, then we have Tuesday, and then Wednesday, and then Thursday, and then the other guys, then Friday, then Saturday, and then Sunday, then Monday, and we would come back to the first day, Tuesday. So as you can see in this case, again, the first 3 days are again get the special treatment. They're going to get the extra. The 3 remainders are going to go to the first 3 guys. But in this case, that's not good. As we can see, Wednesday, there's going to be 5 Wednesdays, right? These first 3 days, they're going to get 5 days each in this month. But the other guys are only going to get 4. So in this case, Monday's only going to get 4 days, but Wednesday has 5 days. So when Tuesday is first, we can see that's not what we want. So hopefully you can see what we're just trying to do here. Now if we do Wednesday, we have Wednesday, Thursday, Friday. Again, this is not going to be good because then the Wednesday, it's going to get 5 days because they're one of the first 3 guys. Then the other guys, Monday is going to be one of the other guys. And Monday's only going to get 4 days. So that's not good either. So we have Thursday. And then we have Friday and Saturday. So these 3 guys get the treatment. Everybody else, including the Mondays and the Wednesdays, because Monday and Wednesday is going to be some of the other few days, and these guys only get 4 days. So this works. When Thursday's first, that works. Because Thursday, Friday, and Saturday, these guys get 5 days each, and then the rest of the guys only get 4. So as you can see, the pattern is the first 3 guys that start off the month, they're going to get 5 days. But everyone else is only going to get 4. Simply from the pattern of the remainder of 3. So we know Thursday is also good. Now, if we try Friday, then that's Friday, Saturday, Sunday, and then this is also good because in the Mondays and the Monday and Wednesday is also going to be one of the last few guys, and we know the last few guys are going to be 4, are only going to get 4 days, so Friday works as well. Now let's try Saturday, and we would have Saturday, Sunday, Monday, and then the rest of the guys. But this wouldn't work because that Monday's the only guy. Monday and then Thursday is going to be one of the other guys. Monday's one of the guys that's getting 5 days. Wednesday, sorry. Wednesday is going to be one of these guys. Wednesday is only going to get 4 because we know the first 3 guys get 5 days, the other guys only get 4. So Saturday is not going to work as the first date. Then we try Sunday, Monday, Tuesday. This is not going to work as well because Monday is one of the first 3 guys. And then Wednesday is going to be one of the other guys. That's not going to work as well. And you can keep on trying this, and we can see that the only 3 guys that can work as the first day of the month is Monday, Thursday, and Friday, and our answer is B. So this question just relied on us knowing the structure of how dates work in a month, right? Because we noticed that, first of all, how many of these periods do we have where we have Monday, Tuesday, Wednesday, we have a whole week, and then we loop back. Well, that's just the definition of a week, so we divide it. 31 divided by 7 is 4. So we're going to have 4 of these weeks, right? 4 of these equal weeks, but then there's a remainder of 3. That means that because we're a remainder of 3, that means we have to go back and have 3 more days. So that means that the first 3 dates of the month, they are going to get the extra day, right? They're going to have 5 days rather than the other guys only have 4 days. So all I have to do is try each of these guys, Monday, Tuesday, Wednesday, as the first guy, see whether Monday and Wednesday both get the same number of days. So that's kind of the structure for how this question is going to work. Problem 6. A circle is centered at O. AB is a diameter, and C is a point on the circle with COB equals 50. Alright, so we know we have O here, and we have a diameter of AB. Oh, that's so bad. It has to go through O. No. Alright, there we go. That's good enough. And C is a point on a circle such that angle COB. So we have COB. This is equal to 50 degrees. What is the degree measure of angle CAB? And this question is actually extremely easy. It only requires you knowing one fact. And this is a very fact you should have known from the beginning, get-go. Is this fact. Let's say you have we first know obviously the central angle. We know a central angle is an angle that is centered at the center of the circle. In this case, let's call the central angle, if this angle is x, then we know the simple fact in geometry is that the arc length is also going to be x degrees. Alright, but there's also another fact that you need to know is that is an inscribed angle. And an inscribed angle, we know an inscribed angle, that's an angle where its vertex is also on the circle. And let's call this inscribed angle A. Then the arc that corresponds to this angle A, the arc that gets subtended, in this case this arc, we know it's going to have double A, 2A. This is a fact of geometry you need to know. If you don't know, go back and review central angles and inscribed angles in a circle. So these 2 facts just pretty much allow us to easily solve this question. So we know based on the central angle, COB, this angle is 50 degrees. That means arc CB is 50 degrees. Now, since angle CAB subtends arc CB as well, right? Because angle CAB is pointing at arc CB. Based on the second fact here, that means that the inscribed angle is half of the arc it subtends, right? So since the arc it subtends is 50, we know angle CAB. Based on our second inscribed angle fact, we know it's going to be half of arc CB. But arc CB is 50 degrees, so it's just 50 over 2, which is 25. And our answer is B. Problem 7. A triangle has sidelines 10, 10, and 12. A rectangle has width 4, and the area is equal to the area of this triangle. Find the perimeter of this rectangle. Alright, so we have a triangle that's very special because it has 2 sidelines that are equal. We know that means it's an isosceles triangle because it has 2 sidelines of 10. And we know a rectangle that has width 4 and has its area equal to the area of the triangle. So let's find the area of a triangle first. Now there's a very key formula, key fact that you know that will always solve how to find the area for an isosceles triangle. And that's this fact. That's if you drop down the height from an isosceles triangle, then it's going to cut the base into 2 equal lengths. If you drop down height, so it's going to be a right angle, it always cuts the base into 2 equal lengths. Now, since we know the whole base is 12, that means each of these lengths is just half of 12, or 6. Now we can find the height using a Pythagorean theorem. So we know this is the 10, this is the 6, 8, 10 Pythagorean triangle, right triangle. If you don't know, you can also use the Pythagorean theorem to find the height is 8. But again, this is the 6, 8, 10 our triangle, so we automatically know the height is going to be 8. So what is the area of our triangle? That's going to be base, which is 12, times height, which is 8, divided by 2. Alright, 12 divided by 2 is 6, so just 6 times 8, which is 48. That's the area of our triangle, but we know that's also going to be equal to the area of our rectangle. Now we know the area of a rectangle is going to be width, length times width. Let's call it length L, since we don't know what that is yet. But we know the area of a rectangle is length times width, or 4L in our case. But we know this is equal to 48 because they say the area of the rectangle is equal to the area of the right triangle, And now from this equation, 48 equals 4L. You can see L is 48 over 4, which is 12. Now let's find the perimeter of this triangle. So we're gonna add up the side lengths, 4 plus 12. We also have this side length, which we know is 4 as well, because opposite sides in a rectangle are equal. And then this length again, that's going to be 12. So our perimeter is 4 plus 12 plus 4 plus 12. 4 plus 12 is 16. 4 plus 12 is 16. Our answer is 16 plus 16, which is 32. And our answer is D. Problem 8. A ticket to a school play costs X dollars, where X is a whole number. A group of 9th graders buys tickets that cost a total of $48. A group of 10th graders buy a ticket costing a total of $64. How many values of X are possible? So we don't know the number of 9th graders and we don't know the number of 10th graders. So let's call the number of 9th graders N and the number of 10th graders T. Clearly N and T are both integers, right? Because they have to be. You can't have half of a student. That wouldn't make any sense. So now let's use the fact that the group of 9th graders that buy tickets, the total cost was $48. Since there's there's N 9th graders, and each ticket costs X dollars, the total amount of money they spent is N times X, right? N X dollars for each of the N 9th graders. And we know this is equal to 48. In a similar manner, we know from the second equation that there's T 10th graders, and each ticket costs X dollars, so the total amount of money these T students spent was T times X, right? Each of the T students spent X dollars, and their tickets cost a total of $64. You want to find the number of values for X. Now what we can see here is that X is common to both the first and second equation. And what does this mean? Well, X, we know X times N is 48. Since both X and N are integers, this means that X has to be a factor of 48, right? Because we know X times another integer is 48. So that means by definition of a factor, that means X has to be a factor because X times something is 48. Factor of 48. Similarly, from the second equation, we know X also has to be a factor of 64 because X times another integer, T, is 64. So this X also has to be a factor of 64. So essentially this question is just finding the common factors of 48 and 64. That's what the question boils down to. Now we know if a number is a factor of both, if X is a factor of both numbers, then that means X is also a factor of the greatest common divisor of these two numbers. Right? That's a fact that we should know. And it makes sense too, because the greatest common factor, by definition, it's going to contain all of the other factors in it because it's the greatest factor. So let's find the greatest common factor of 48 and 64. Obviously, you can also just list out the factors of 48 and 64 and find the common factors, but I think this way is a little bit faster. So we know 48 is 3 times 16, 64 is 4 times 16, so obviously they both have a common factor of 16. Is that the greatest common factor though? Yes, because 3 and 4 don't share any common factors anymore, so we can see 16 is the greatest common divisor of 48 and 64. Now I know X, but X has to be a factor of 16 because we just said if it's a factor of both of these numbers, it's also going to be a factor of its greatest common divisor. So we're just trying to list the greatest common the factors of 16. That's 1, 2, 3, no, 3 is not a factor of 16, then 4, 5, no, 6, no, 7, no, 8, yes, 9, no, 10, 11, 12, 13, 14, all the way, finally 16. So these are going to be the 5 possible values for X because these are the 5 factors of 16, and our answer is E. Problem 9. Lucky Larry's teacher asked him to substitute numbers for A, B, C, D, and E in the expression A in this expression here. Now, Larry, he ignored the parentheses, but added and subtracted correctly, and obtained the correct answer by correct result by coincidence. Now, we know the numbers Larry substituted for A, B, C, and D are 1, 2, 3, and 4, respectively. What number did Larry substitute for E? Alright, so we're just going to calculate this expression using the wrong way, using Larry's way. And we're also going to calculate the right way, and we're going to know they're both equal because he obtained the correct result even though he used the wrong method. So his wrong method is just completely ignoring the parentheses. So all he does is just A minus B. So we're just ignoring the parentheses, then minus C, then minus D, then plus E. So this is Larry's way. We know this is equal to the correct result. So the correct result is not ignoring the parentheses. So let's do that. It's not ignoring the parentheses. So we're going to have to evaluate from the inside out. So we have C minus, in parentheses, D plus E. So let me write that down again. So A minus, so we have A minus in parentheses B minus. And then looking at the innermost, we have C minus in parentheses D plus E. So we have to distribute the negative to both D and E, so it becomes C minus D minus E. So we're just removing the parentheses one step at a time. Now let's do that once again. So I have A minus in parentheses, B minus. Again, we're going to look at this thing and again distribute the negative to each of these three expressions. So minus C, that's just negative C. Then but minus negative D, that's plus D, because two negatives make a positive. Then minus negative E, that becomes a positive E. Finally, let's do that one more time. So we have A. Well, let's distribute the negative to each of these terms. So we have just minus B. Minus negative C, that's plus C. But we still have a minus D, because negative and positive D, that's negative D. And E, negative E, that's just negative E. And we know these two expressions are equal. Right? He did it the wrong way, but it still was correct. Now, let's just solve for E, because we want to know what number did he substitute for E. So let's cancel out the A's. We can cancel out the negative B's. We can cancel out the negative B's. So have negative C plus E equals C minus E. Now let's plug in what is the value of C. C was 3. Alright, so we know negative 3 plus E equals C minus, equals 3 minus E. Let's bring E to the other side, so we have 2E equals, bring the negative 3 to the other side, that's 6. So 2E equals 6, that means E equals 3, so our answer is D. In this question, this was not very difficult at all. It was pretty straightforward from the get-go. We knew what we had to do. We did it the first way, which was just ignoring the parentheses, and we also did the second way where we had to actually use the parentheses and distribute. Remember to distribute the negatives to everything inside the parentheses, and we just did that a couple of times to get the correct result. Problem 10. Shelby drives her scooter at a speed of 30 miles per hour if it is not raining, and 20 miles per hour if it is raining. Today she drove in the sun in the morning and in the rain in the evening for a total of 16 miles in 40 minutes. How many minutes did she drive in the rain? Alright, we're just going to use the formula distance equals rate times time here, right? So, first of all, what we can see here is that our units are consistent. In this case, we have miles per hour, but we have 40 minutes. So let's change the 40 minutes. Let's change the 40 minutes to hours. So we know there's 60 minutes in an hour, so let's just divide that by 60, cancel out the zeros. That is 4 over 6, which is 2 over 3 hours. So we know that she spent a total of 2/3 of an hour riding her scooter. So we want to know how many minutes she drove in the rain. So let's say she drove X minutes in the rain. Then that means since she drove a total of 2/3 of an hour today, then the amount of minutes she drove, if it's not raining, is simply 2 over 3 minus X, right? Because we know the total amount of time she spent driving in total was 2/3 of an hour. Now let's use the formula distance equals rate times time. So the distance she drove, not raining, so let's call that not raining, is equal to speed, which we know is 30 miles per hour, times time, which is 2 over 3 minus X. Now we know the distance she drove in the rain was speed, which is 20, times time, which is just x. Now what we do know is the total amount of time she spent driving, both in the rain and in the morning. So if we add these up, because we know the total amount of distance she drove in the rain plus the total minutes she didn't drive in the rain has to be equal to 16 miles. So if we just add these up, we have 16, because these two add up to 16, equals, and we have these two expressions. And let's just solve for x. So 30 times 2 over 3 minus x plus 20x. Okay, so I have 16 equals, let's distribute 30 times 2 over 3. Let's just multiply 30 times 2 over 3. 30 over 3 is just 10, so it's just 10 times 2, which is 20. So I have 20, and then 30 minus x, just minus 30x, plus 20x. Alright, so we have 16 equals 20, minus 30x plus 20x, that's plus minus 10x. And let's solve for x. So we have 20, we have 20 minus 16 equals 10x. We just rearranged our equation here. So I have 4 equals 10x. That means x equals 4 over 10. But remember that our units were in hours. They want our answer in minutes. So 4 over 10 hours. In order to convert that to minutes, let's just multiply that by 60. 60 divided by 10 is 6. So our answer is 4 times 10, which is 24. And we can see our answer is C.